Hi, everybody. This is Joanne with Read Science, and I am joined as always by Jeff Shaumeyer, my co-host. And today we are joined by Helen Scales, who is sitting in the UK currently. She is the author of several books, including the one we will focus on today, The Brilliant Abyss, Exploring the Majestic Hidden Life of the Deep Ocean and the Looming Threat that Imperils It. And I have read past books of Helen's and loved them. So I was so excited that she had a new book and we had the opportunity to speak with her today. Do you want to say hi to everybody, Helen?
Hi, everyone. Thanks for that lovely introduction. It's so nice to be here. Thank you for having me.
We're so glad. So let me read your bio from the back of the book. And Helen Scales, PhD, is a marine biologist, writer, and public broadcaster. She is the author of Spirals in Time, The Secret Life and Curious Afterlife of Seashells, and Eye of the Shoal, A Fish Watcher's Guide to Life, the Ocean, and Everything. She has written for National Geographic, The Guardian, New Scientist, BBC Wildlife Magazine, and BBC Focus, among others. Everywhere our favorite authors write, I think, and appears regularly on BBC Radio. She teaches marine biology and science writing at Cambridge University and advises the marine conservation charity Sea Changers. And you're sitting now in Cambridge.
That's right.
Is that right?
Yes,
Great.
that is correct. So not very close to the ocean, sadly, but I have some fish to keep me company, just in case I forget what it's all about.
Very good. I'm so glad you're here.
Oh, it's
really a pleasure.
Thank you so much.
It is a pleasure. And I don't always start with glowing reviews or anything, but I think Joanne and I both found your book very rewarding, very enlightening, and great fun to read. But we also found that we both had some very strong reactions. There was astounded delight at some of the biology and the physical processes we learned about in the deep ocean, and also our absolute horror at all the countries and corporations drooling to exploit the deep sea any way they can. And I think we'll get to all that. But to begin, I want to read out a couple of quotations and an observation I made that all relate to something I thought was an interesting theme of the entire book, and then ask you whether I was right about that and what you think. First quotation: "The oceans have always shaped human lives, but the surface and the very edges have so far mattered the most." Second quotation: "For the longest time, the only things people thought lived in the deep ocean were monsters, demons, and deities." And I remember the time when you talk about this time not so long ago, but in living memory, when people thought the deep ocean was basically empty. There was maybe a whale over there and things, and that informed your discussion of deep sea mining and nodules back from the day when people thought that, well, these nodules have metals we can use and we'll just suck them up because nothing lives down there and nobody cares. And now we know a lot better. And then the observation when you were talking about hydrothermal vents is, once chemosynthetic life was found near hydrothermal vents, it also began to be found elsewhere. And so my question is, what does all of this, the empty deep seas, the lack of, who knew that chemosynthetic life could even exist? What does this say about scientists' preconceptions and scientific discovery and how it's inhibited or not? I thought I'd start with something easy.
Okay, yeah, easy peasy. Well, here's my stock answer to that. No, there's a lovely quote.
But that's a question that always interests me when I'm reading things and thinking, and it just seemed to keep bubbling to the surface to say.
No, absolutely. I think it is a theme through the book, which is, a part of it, I think, is this. I guess it's part of human nature to look for more of what we already know and to look in a way that fits with our preconceptions to our model of the world in our minds and in our, whether it's just everyday people imagining what the world is like and sort of drawing those boundaries in our minds of like, well, there's nothing there, or going back to, those ancient maps of here be beasts around the edges of the bits we don't know, and kind of imagining what might be there, but kind of really, assuming that there isn't much of any great interest. So I guess, I suppose there's two things here I'm trying to kind of grasp at. One is that sort of general perception of this big empty space. And I think that lingers a lot today. And I think that underpins sort of why, and we'll get to this sort of ideas of how people feel about the exploitation of the deep ocean.
Yeah.
And I think we've got a long way to go before it does genuinely become something that more people can kind of bring really into their hearts in terms of caring or knowing and caring about what happens in this completely unseen, this hidden part of the world. Even though the scientists are showing us what's there, it's still very easy to ignore it. So I guess that's part of it, and I think that's always been an issue with the ocean. I think I think it underpins a lot of my work, which is trying to push against that sort of like we can't see it. It's this blue blanket of ocean. Everything down there is hidden, and therefore it's disconnected from us because we can't see it. So it's
something as simple as being able to see it is a big deal in that case, right?
I think so. Yeah, I do. I think so. I think it's hard for us to generally to appreciate that there are these really critical connections between, well, everywhere throughout the entirety of our living planet, which is all the way to the bottom of the deepest part of the ocean, as we now know. So I think there's that boundary between water and air it's a physical boundary, but I also think it's an incredible mental boundary for us thinking about this place. So even as the science now is starting to show us just how interconnected everything is, physically, chemically, the heat that's moving around, just the sheer fact that we're all species living on this one planet of ours, whether we live in the bottom of the Mariana Trench up a mountain or strolling around on a beach, we're all in this together. And that's a really big concept to get our heads around too, sort of generally. But I want to pick up another point in terms of the science. There really is this sort of, we look for what we know and then you find more of that thing. And it's those kind of, it's like the discovery of hydrothermal vents. So suddenly, boom, like this whole new thing, this whole bubble, universe almost explodes because suddenly you realize it's not as we thought it was. And for me, that's why I find the deep ocean so exciting. Because you do have those extraordinary moments of, oh, wait, it's not what we thought it was. This is a whole new way of life. This is a whole new type of living, a whole new way, the geological breakthroughs, you get all those kind of things. But it often just takes kind of those serendipitous, like it wasn't an intention to go looking for hydrothermal vents and what lives there. I mean, sure, they were looking for the chemistry and the geology, but no one was going there to look for animals. They were completely blown away when they saw anything was living there at all. Same with things like those wonderful bone-eating worms, one of my favorite Geocidae.
Yes.
And it was a total surprise. No one was looking for them. No one was looking at bones. And yet they came across this dead whale lying in the Monterey Canyon. There he is. I should say, Ruby the whale. I don't know if they figured out. It was a female whale. Yeah, somehow they figured out from the bones. Yeah. Covered in this pink stuff, which turned out to be a whole new life form that no one had ever seen before. But it was a total chance discovery. As soon as you find one, then people started looking and we found them everywhere. Yeah. And I love that too. It's like you open this little window and go, hey, wait a minute. But it's often that chance first discovery that makes it kind of, you realize you should go look there. And I guess you just don't know what other windows we're going to open, I guess.
How hard was it to convince? I remember hydrothermal things sort of happening in the popular press. It's like, how hard was that to convince people that's like, no, look, there's life there and they metabolize chemistry stuff? Because
it took a couple of years scientifically to figure that out. I mean, that first discovery, I think, was I'm pretty sure it was sort of, National Geographic were sort of filming it and there was pictures and so on.
But it was more figuring out than denying and having to convince them, wasn't it?
No, I think, it's showing people those images was very powerful. And it did take a couple of years and some really smart scientists to figure out how this thing was possible and how this ecosystem, this incredibly rich ecosystem, was able to support itself in such extreme conditions. So no, I think when the science comes along, people kind of latch onto it. It's getting to that point of doing the science, which is sometimes
and the seeing is really important. The emphasis that the remark that you made about how our main familiarity is with the surface and with the seashores, which is very two-dimensional. we're still, I think most of us, me too, reading the book, I discovered it's like, I really have no idea how unfathomably big the ocean is.
Yeah.
And how deep
Yeah.
it is. And
Yeah.
it's big.
I mean, it's so big. I mean, I tried in a couple of ways in the book to try and figure out ways of demonstrating that. But even
My favorite was the marble.
The marble. Yeah, did you like that? That was fun.
I love
the marble was fun.
So the idea being, if you just took a normal glass marble, I haven't got one to hand, but anyway, I usually wave one at people when I'm talking about this. But yeah, the idea if you sailed out over to off to a part of really deep ocean, dropped it over the side of your ship, how long would it take to get through all the different layers of the ocean? It was partly an idea of showing that it's like this kind of layers of like in a sundae glass. I don't know if that's the word you would use in American.
Parfait,
like,
maybe
dessert glass.
A trifle. Perhaps.
A trifle glass, yeah. Nice cocktail, maybe. Anyway, but you've got all these different layers: the twilight zone, the midnight zone, the abyss, and then the Hadal zone at the bottom. And that, it would take like 6 hours to get to the very deepest trenches in the Hadal zone at the very bottom. And that is still, it's like that's just like, it's still just crazy, but crazy big.
Well, I love that. I love that you said that. And actually, just before we leave the hydrothermal vent thing, I remember being in middle school. So everyone start calculating my age when the teachers had caught on to this big news and started telling us about it. And I was on Guam. So those watching who don't know this, my dad was in the Air Force and I lived on Guam. So surrounded by ocean for 6 years. Yeah, and really close to the Marianas Trench. Right.
Course,
so some research vessels would take off from there.
Yeah.
So
and you went so far. I mean, okay, the Galapagos is probably a fair old sail from Guam, but
for the hydrothermal vents, that's near the Galapagos.
That was the first ones, was the Galapagos ones. I'm sure there are lots. I know, a lot closer to Guam as well. And the Pacific is just generally a very exciting, geologically very exciting place to be, an oceanic. The stuff is amazing around there. So I know they've done some fantastic research more recently, actually, on seamounts and things around Guam. There's been some wonderful NOAA expeditions with amazing image brought back.
It made me think of when I was a graduate student, and about the time of the explosion of interest and discovery of deterministic chaos everywhere. It's like somebody found, they found out it could happen. They discovered these nonlinear systems could do this. You got strange attractors and all of this, and suddenly they were everywhere. And it's like, now hydrothermal vents seem to be everywhere you look, almost, don't they?
Oh, definitely in the places we know they form. Joanne, I'd love to ask, actually, do you remember how you felt when those discoveries were coming? Like, what did you think about that sort of, was it like alien life on Earth, or like, how did it?
Yeah. The lipstick tube worms, those things were like, what? So now I was already a curious kid. My path towards science seemed to already be determined. But things like that just really, it blew me away. And I'm so grateful to the teacher to pointing it out. Now, my parents may have, but I doubt it. I remember being in school when I heard about it.
So cool.
And knowing that really, even though it wasn't near Guam, I'm here where, they were trying to do research and everything else. So that was really just so cool. Exciting. Yeah. I remember being very excited about that, and that those things are living there.
Yeah.
Impossible.
And the fact that we're still finding so much more. I mean, there's basically vents dotted all the way along the edges of tectonic plates, wherever they may be throughout the oceans. A lot of them many have been studied, but many haven't. And pretty much every time somebody goes to look at a new one, it's like, oh, here's another weird thing we didn't know existed. Whether it was a yeti crab or a scaly-foot snail, or whoever knows what else is going to come next. But there's this amazing regional differences in vent life. They are very different in different parts of the Pacific. Yeah, those are
These are all these crabs. Oh my gosh, it's like a mound of white crabs.
Huge mound of crabs, exactly. Those are a type of yeti crabs that were originally discovered again in the Pacific species. These ones, I think those particular ones those are Antarctic actually, but they were originally discovered in the Pacific. There's various different species, and they kind of dot themselves along the vents, these kind of linear, because the edges of plates are kind of form these lines across the planet, almost like the stitching, if you like, between the tectonic plates. And the vents form there. And these ones, these are Antarctica. And you can see the density of life there. And that's the sort of thing you see, in the middle of a fairly sparsely populated deep ocean. Suddenly it's like, poof, okay, hang on, what's going on here? And again, it's this reliance on this sort of chemical energy as opposed to sunlight, which is driving these ecosystems and is still being, there's still so many questions about how these things are occupied, how they move around, all these kind of things.
Yeah.
I'm amazed at the number of things that have no pigment, which you don't need because it's dark and doesn't matter, right?
Yeah, but then some of it is colorful too, and that's pretty
very
good.
color. That's right.
Yeah, the kind of the reds. We think the red color in the deep ocean is a camouflage thing, because at least that's the vampire squid, which is looking beautiful there. The
very nice
squid.
Picture.
But the red coloration we think helps to make them look really indistinct, and that's kind of mid waters where there's well, there's no light, but I think if there's any light at all, it's bioluminescence, which is generally blue and green. So the reds are kind of still hidden away.
Blends in. So, and you did have quite some, a bit of explanation of the scaly foot snail, which is
stunning.
Isn't that a beautiful picture? That was really lovely. It was taken by for me for the book by a wonderful scientist called Julia Sigwart, who I spoke to as well, and she was involved in doing a lot of studies of these guys. They only live, these ones are very strange. Their shells are made of an iron-based compound, and there's nothing else we've discovered that does that. They have these tri-layered shells, and then the feet covered in scales.
Right, and those are the iron, and they're iron-based scales
as well
too.
As well, and so it's been latterly discovered. when they originally found, it's one of these things I love as well. You see something, something's discovered, especially animals in the deep ocean. We find things, and people go, that's especially something like that. These weird snails with these funny feet, and you think, okay, why is that?
Why?
What led to that? Was the evolutionary pathway led to that?
Why
so
not?
the initial assumptions, and in fact, if you read my earlier book, Spirals in Time, I talk about these guys just briefly. And the theories back then were, well, those plates must be some kind of protective measure, like they're being attacked by something, right? They're being attacked by crabs or by other snails, which have these like poison darts to hunt with. Maybe they're protecting themselves. And then it turns out down the line, just a few years, more researchers have looked in detail, and they've taken some of these scales and they've looked at them under the microscope and found they're full of these tiny wee tubes, like nanoscopic tubes. And in fact, it's this incredible like physical process whereby one of the problems with living in these vents, and what they're doing is they're relying on these bacteria that live inside them. They have these symbioses based on these chemical supping microbes, which are harnessing energy from chemicals coming out of the seabed. So it's like this dark equivalent to photosynthesis. So the chemosynthesis is producing carbohydrates, producing energy, but using chemical energy as opposed to sun energy. This energy from sunlight. So these snails, as well as the worms we've talked about, the giant tube worms and yeti crabs, everything else, are basically relying on these microbes. And the snails, like many, have them living inside them. But as a consequence of that process, that chemical process, they produce sulfur, which is toxic to many organisms, especially to snails. And these feet are pulling that sulfur out of their bodies down these tiny tubes like a tailpipe on a car. And then it's reacting with metals in the water and forming these iron compounds, which are then laying down on the surface. And so it's not an external threat, it's an internal threat that they're protecting themselves from. And no one thought of that when they first looked at them. But then you look a bit closer and you realize that's how they're doing it. That's one way they're surviving in this ridiculously extreme environment of a hydrothermal vent. And it's amazing. It's really cool.
You wonder after the fact why everyone is so surprised, because you've given us this vivid feeling of the ocean, so unimaginably huge, and the water itself and the layers are so many different ecological niches, not to mention the surface, which is not just a featureless surface, but has topography of miles in variety, of mountain ranges that are huge, of deep canyons that are huge, of hot spots, of brine pools, of all sorts of things. And it seems to me there's an awful lot of Darwinism going on for people. It's like, it's a bunch of bunk. It's like, look at every place you look, there's another weird thing doing something that we couldn't even imagine before, because that's what they had to work in this environmental niche. And diversity of life evolves in the most interesting ways.
It really does. I think that's a huge lesson that the deep ocean tells us, and it's why I think, quite rightly, space scientists and astrozoologists, whatever you want to call them, people wondering about what life might be like elsewhere, the deep ocean has so much to tell us, because it's showing us that life just finds a way, no matter how. Where or how.
You asked about reporting. The thing I remember from the earliest discovery of hydrothermal vents, and then the fact that there are animals living there in places that animals were presumed not to be able to live at all, doing chemosynthesis, also unimaginable, was all about exobiology and things like, could there be life on other planets? Science finds new ways, animals that we've never thought of before.
Oh yeah, I mean, there's hydrothermal vents on is it Europa and Enceladus? I mean, go check. You never know.
For all those years that I grew up of people saying, obviously life needs this and this and this, it's like, boy, I think all of those were wrong. And that's exciting.
Life does, but now we know that it's a totally different way of being, like a whole new way of having biological life. And who knows what else we might find too. I mean, I think that's it. We mustn't just limit our horizons anymore, because you never know what might come up. But the deep ocean tells us such a big lesson, and just what's possible. Yeah.
But it is exciting with your submersible and things, because it is a time when there's great value in just looking at things and places. That's always very exciting.
Yeah, I mean, I think what I've found a lot with the sort of deep sea biology community is that they're genuinely kind of part scientists, part explorers.
Yes.
And that's, it's not to belittle just exploring as its own thing, but I mean, it's because, pretty much anytime anyone goes, I mean, people do return to the same places to do studies and so on, but pretty much every time you look into the deep ocean, no one's looked at that bit before. That piece of water, that piece of seafloor, it's rare that you kind of go back very much. So you are exploring, and because as we've touched on the diversity of the geology and the topography and the biology in the deep ocean, you're always going to find new things. So yeah, but it's sort of translating, I think, that exploration into science as well. It's like, what do we do with that knowledge of knowing these things exist? And there's always the kind of the next level sort of, aside from just I think there is something to be said for absolutely knowing what we share our planet with, and coming up with a better idea of the sorts of the diversity of life that's out there. But it's those, for me, the exciting parts is when those big lessons come, like things like a huge breakthrough like chemosynthesis, or new ecosystems, or a new understanding of some. A lot of the time, to be honest, deep sea biology is like, how the hell are you doing that? Like, that's the big question. How is this possible? How are you feeding? How are you finding a mate? And so many of those questions are still unanswered. That there's always those kind of.
Do we in the public develop more empathy when we find out that whales dive so deeply, and then there you are with the question? It's like, and how in the world do they do that? Yeah. I enjoyed the whole discussion about sticky myoglobins and things, so that and then the fact that they're down hunting for squids who may be oxygen deprived, and so they turn a little stupid and they go, oh look, it's a whale, and the whale eats them.
It's pretty smart, isn't it? Yeah, it's like, I've got my own oxygen. You guys just have to tough out with this meager ocean-borne stuff to breathe through, whereas the whales are like in their own little capsules of air, of atmosphere. Yeah.
But you don't find that out about whale blood and the ability to carry oxygen with them in a uniquely evolved way until you find out that they dive to these extraordinary depths and live there.
I mean, I love that as well. I mean, it was really not that long ago, surprisingly recently, there was discovered that sperm whales specifically, these wonderful dive, I mean, there's several, I mean, many whales do dive very deep, but I find the sperm whales the most kind of curious and fascinating, because we do know we're getting to know them better. But it wasn't that long ago that people were like, so how do they hunt? I mean, we know they hunt because we catch them. They've been caught for centuries, and their stomachs are full of the beaks of squid, of really big squid as well, the ones we know live down in the deep. So how are they catching them? What are they doing? Like, how do they do it? Yeah, that question. Are they just hanging there and waiting for stuff to come by? Are they luring them in with some sort of like glowing white belly. And then, it turns out they're like bats and they have sonar and they're chasing around. And I love this. I just love this picture of finally someone was like, we've got this device which shows us where they're moving and how far, and we can listen and we can get the movements. And we're basically tracking them doing these like chasing after a squid, and it does a handbrake turn at the end and sucks the squid in. And they, that we know that now. And this is all happening, by the way, at like 3,000, 4,000 feet down.
Amazing.
And it's that again, it's answering those questions is how this all works that opens up this whole new kind of like, a whole new understanding of these animals and what they're doing and how they're communicating, and
a new appreciation too. I hope that's what made the section on exploitation so disappointing. And there all these interesting facts, like here's one that just jumped out. It's a tiny little fact, and yet it's kind of a shocking fact. And in 1930s Europe, almost half of all margarine spreads were made from hydrogenated whale oil.
Yep. Yeah.
I know. Right?
We still killed whales just to make butter substitutes.
Yeah.
I know. I remember. Talking about the kind of what sort of from a childhood sort of coming through. I remember being kind of in the schoolyard. It was like, you shouldn't lick stamps or envelopes because that's whale. That's made out of whales, or lipstick as well.
Spermaceti
like,
or whatever.
Yeah, and that was the kind of, we would talk about it in the schoolyard. And I think looking back, at the time I don't think I really understood, and I didn't really know what that meant, or if it was true. But looking back, I think it could have been. We're talking that was like in the early 80s. The moratorium didn't come in until 82. It might have just been the tail end of like, my mom and dad used to kind of thing, whatever. But still really shocking that absolutely within lifetime, this was normal. It was either people didn't realize, or it was completely normal for whale to be this commercial, like industrial product that was getting into into everyone's diets and
everything.
lives.
Yeah. Interestingly, just recently I went to Nantucket and they have a whaling museum there. And it was so fascinating. Now, I thought, I'm not going to care about this, but the biology of it all, and and then how things changed. Whales were becoming in short supply. Petroleum came along, so luckily we didn't need to continue to kill sperm whales and puncture this gland to have all their oil spill out. Right?
Exactly.
It was more fascinating than I thought. And they had a full sperm whale skeleton there because one had washed up on the beach in like 1998 or something. And they even had this little documentary about how, they were trying, okay, how can we take this apart? How can we, and they discovered that the old tools were actually better at this, removing the blubber than, the new fancier tools. And, because nobody's been doing this in recent years.
Right.
And then the surprise of actually puncturing that gland with the oil and how much came out of the spermaceti oil came out was really astonishing to them.
Gosh.
And so I was like, it's funny, we move away from doing those things and how much we even forget. So there's discovery and then there's rediscovery because So if you haven't been to that museum, I recommend it. I wasn't sure. Everyone said go visit it when you're on Nantucket. I'm like, really? And then, but it was a surprise, a gem, really.
That's awesome. I'm actually going to be doing it, and again, not in person, sadly, but I am going to do a talk in Nantucket Athenaeum. So I shall ask.
Oh them. Yes,
ask about the whale.
Yeah. Oh yeah. Well, because they're very proud of this history.
Yeah.
And, but and also some of the oil they had was responsible for a very big fire that destroyed much of the town.